Hello everyone, this is Saurabh from EduReka, and in today's session we are going to focus on NumPy module available in Python. So let us move forward and have a look at the agenda for today. First we'll see what is NumPy. Then we are going to compare it with list and we'll see why it is better than list. Then we are going to see various operations that we can perform with the NumPy arrays, and there are certain special functions as well that we are going to focus on later in the session. So are we all clear with the agenda? Kindly give me a quick confirmation by writing down in the chat box. Devon says he's clear, so does Theon. Janet says move forward. Dave says go on. Lavanya, Jason, Ayushi, Jagrati, Neha. Alright, fine guys. I've got a confirmation from almost everyone. So let us move forward and understand what exactly is NumPy. So what is NumPy? NumPy is basically a module, or you can say a library, that is available in Python for scientific computing. Now it contains a lot of things. It contains a powerful n-dimensional array object, then tools for integrating with C, C++. It is also very useful in linear algebra, Fourier transform, and random number capabilities. Now let me tell you guys, NumPy can also be used as an efficient multi-dimensional container for data, for generic data. Now let me tell you what exactly is multi-dimensional array. Now over here, this picture actually depicts multi-dimensional array. So we have various elements that are stored in their respective memory locations. So we have 1, 2, 3 in their own memory locations. Now why is it two-dimensional? It is two-dimensional because it has rows as well as columns. So you can see we have 3 columns and we have 4 rows available. So that is the reason why it becomes a two-dimensional array. So if I would have had only one row, then I would have said that it is a one-dimensional array. But since it contains rows as well as columns, that is, it is represented in a matrix form. That is why we call this as a two-dimensional array. So I hope we are clear with what exactly two-dimensional array is. If you have any questions or doubts, you can ask me. Any questions? Anindo, Ayushi, Jagrati, Neha, Lavanya, Jason, Theon, Dave? Alright, fine guys. So we have no questions. So let me open my PyCharm and I'll tell you practically how to actually create a NumPy array. So this is my PyCharm guys. Over here, the first thing that you need to do is first install the NumPy module. And how you're going to do that, click on File, go to Settings tab, and you'll see the Project Interpreter option. And on the right hand side, you'll see a plus symbol. Just go on and type the module that you want to install. So I'm going to install NumPy. Just go there, click on it and install package. I've already done that, so I'm not going to repeat it. So this is my PyCharm. So first thing that I need to do is import NumPy as NP. Now after that, I need to create a NumPy array. So for that, I'm going to define a variable, let it be A, and I'm going to type in here np.array and certain elements inside it. So I'm going to put in 1, 2, 3 and print it. That's all. So this will actually print a single dimensional array. So 1, 2, 3 has appeared. Now if I want to convert this to a 2D array, so for that I'll keep this in parentheses. And after a comma, I'll add one more element and I'm going to give certain values inside that. So I can give, say, 4, 5, and 6. Now go ahead and print this. So as you can see that it is now a two-dimensional array. So this is how you actually create arrays using NumPy module. If you have any questions or doubts, you can ask me. Dave says he's clear. So does Theon, Anindo, Ayushi, Jagrati, fine. Alright, so we have no questions. So now I'm going to open my slides and we'll move forward and see what is our next topic. Now let us see why are we using NumPy instead of a list. Alright, so many of you might be thinking, why are we using NumPy when we have lists? Alright, so basically we use NumPy because of 3 main reasons. The first thing is it occupies less memory when compared to lists. Then it is actually pretty fast when you compare it with list, and at the same time it is very convenient to work with NumPy. So these are the 3 major advantages that NumPy has over lists, and that is the reason why we use NumPy instead of lists. Now don't worry, I'm actually going to prove it to you practically by opening my PyCharm. So guys, this is my PyCharm again. So first thing that I need to do is import NumPy as NP. And now what I'm going to do is I'm going to import a couple of more modules. I'm going to import time and I'm going to import sys. Alright, done. So our first step is to actually define a list. And the name that I'm going to give to my list is, say, S. And I'll type in here range 1000. So what this will actually do, it'll actually take all the integer values between 0 to 1000 and it will give it to a variable s. So this list will contain the integer values between 0 to 1000, but it won't include 1000. It will be only there till 999, that is 999. And now I'm going to print the space occupied by this particular list. So for that, what I need to do is I need to type in print sys dot get size of any one element. Okay, so you can give 3, 4, 5, anything. I'm going to give it as 5, any one element, and multiply that with the length of my list. That's all. So this will actually give me the space that has been occupied by the list, because sys.getSizeOf will actually give me the memory occupied by one element, and when I multiply that with length of my list, I get the entire memory that has been occupied by my list. Now the same I'm going to do with my NumPy array as well. Let me give a name to that. I'm going to type in d np.a range, and the range will be 1000. Now a range function is pretty much similar to the range which is there. So the same thing will happen here. The integer values between 0 to 1000, but it won't include 1000, will be present in my variable d. So we have created a numpy array. Now let us print the space occupied by it. So the first thing is I'm going to type in here d dot size. So this will actually give me the space occupied by one single element, and when I multiply that with the length of my numpy array, I get the entire memory that is occupied by the numpy array. So I'm going to type in here d dot item size. That's all. Now go ahead and print this. So this actually shows the memory that has been occupied by my list, and this shows the memory that has been occupied by my numpy array. So as you can see, there is quite a lot of difference between both of them. So we have proved our first point that it actually occupies less memory. Now when I talk about numpy array is faster and more convenient than a list. So the next step is I'm going to prove it to you that numpy array is actually faster and more convenient than list. So I'll remove all of this, and so now I'm going to show you that numpy arrays are faster than lists. And at the same time, it is easier and more convenient in order to work with numpy arrays when compared to lists. Let me show you practically. So first what I'm going to do is I'm going to define a variable, say size, which is equal to say 1000, and then I'm going to define two lists. Now what I'm going to do is I'm going to add those two lists, as well as I'm going to add two numpy arrays, which I'm going to define now. And then I'm going to compare the time taken in order to find the sum for list and the sum for numpy arrays. So first let me define two lists and two arrays. So my first list will be equal to range size. Same goes for my second list as well. Just change the name to L2. And now I'm going to define two numpy arrays, a1 equal to np dot a range size. Go ahead and do the same for the second numpy array as well, and change the name as a2. So we have two lists and two arrays, and we need to compute the sum of both of these lists as well as arrays. Now before that, I'm going to define a variable, say start, which is equals to time dot time, and now I'm going to calculate the sum. So I'm going to save that in result, and first I'm going to calculate the sum of list, that is L1 and L2. So for that, what I need to do is I need to run a for loop, because if I directly write L1 plus L2, it is going to give me a result which is nothing but the concatenation of both the lists. So in order to calculate the sum, I need to use for loop. Let me show you how to do that. First I'm going to type in x comma y, and we have already studied loops in detail. For x comma y in zip, and the name of the two lists, that is L1 comma L2. That's all. So what will happen here, it will first take the first element of list L1, and then it will take the first element of list L2. It will calculate the sum, and it will store in result, and it will keep on repeating until the range has been exceeded. Now this is how you calculate sum in lists. But when you talk about arrays, what you need to do is you need to just write in a1 plus a2. That's all. That's why I'm saying that it is more convenient in order to work with numpy arrays when compared to lists. Now our next step is to define the same variable start and initialize it with time.time. And now I'm going to find the sum of my two numpy arrays, which is nothing but a1 plus a2. That's all. And now print the time taken. So print time.time minus start and then multiply it with 1000. Because by default it will take it in seconds and I need to convert it into milliseconds. Now I forgot to actually print the same thing for my list, so I'm going to do it over here. So this will actually give me the time taken by my list in order to compute the sum, and this statement will give me the time taken by my NumPy array in order to compute the sum. So are we all clear till here? If you have any doubts or questions, you can ask me. Any questions, guys? Alright, so we have no questions, so let us go ahead and execute this and we'll see what happens. So it gives me 0 milliseconds because the size is small. Let me just add a couple more zeros. Let's make it 1,000,000. Now go ahead and execute this. Now you can notice the difference that there is a significant change. Lists took 208 milliseconds, whereas NumPy array took almost 67 milliseconds. So there's a huge difference between the compute time of a list as well as NumPy array. That's why I say that NumPy array are faster, convenient, and at the same time they occupy less space when compared to list. So that is the reason why we choose NumPy arrays over list. If you have any questions or doubts, you can ask me. Any questions, guys? Any questions? All right, so we have no questions. So let us go ahead and move forward towards the next topic, that is NumPy operations. So let me go back to my slides. So now is the time to see various operations that you can perform with the NumPy arrays. So you can find the dimension of your array, whether it is a two-dimensional or a single-dimensional array. Then you can even calculate the byte size of each element. It is pretty easy. I'm going to tell you that practically. You don't need to worry about that. And you can even find the data types of the elements that are stored in your array. So if you want to know what is the data type of the elements, you can do that as well. So let me show you these three operations first, and then we'll move forward to the other operations. I'm going to open my PyCharm once more, guys. Let me remove all of this. So we have imported the NumPy module. Now what I'm going to do is I'm going to define a NumPy array. I'm going to name it as A, and I'll write here np.array 1, 2, 3. Put that in parentheses. Now add one more element, say 2, 3, 4. Alright, so it's a two-dimensional array. Now if I want to know whether it's a two-dimensional or a single-dimensional array, so I'm just going to type in print a.endim and it'll give me the dimension. So let me show you that, and I'm going to run this. So it says 2, that means it is a two-dimensional array. So what if I move this part and make it as a single dimensional array? It should give us the result as 1. Let's see if it does that or not, and yep, it gives us 1 as a result. So this is how you actually calculate the dimension of your array. Now if you want to find the byte size of each of the elements, so what you need to do is, instead of endim, you can call a function called item size. Go ahead, execute this, and you'll get, so each element occupies 4 bytes. After that, if you want to know the data type that is stored in the array, so you can just type in here d type. Go ahead, execute this. It should give us integers 32-bit. Alright. So this is how you can actually perform these three functions that I've told you in my slides. It's pretty basic. If you have any questions or doubts, you can ask me. Alright, so we have no questions. So let us proceed with the presentation. Now let us move forward and see what are the other operations that you can perform with NumPy module. So by using NumPy array, you can actually find the size of your array. How you can do that, I'll show you practically. You don't need to worry about that. So when I say size of the array, that means the total number of elements that are present in the array. So if this is an array, so the total number of elements become 4. 1, 2, 3, and 4. Now you can even find the shape of your array. Now what do you mean by shape? So basically the total number of columns and rows. Now over here we have 3 columns and 4 rows. So our shape is actually 3 columns and 4 rows. Now let me show you practically how you can do that. Again, I'm going to open my PyCharm and show you. Let me remove this print statement from here. Now if I want to find the size of my NumPy array, I just need to type in print a.size. That's all you have to do, and it'll give the size of your array. So there are 3 elements. So if I go on and add some more elements, say 4, 5, 6, 7, then if I execute this, you'll see that 7 elements have appeared. That means the total number of elements in my array is 7. Then comes the shape part that I was talking about. So in order to find the shape, what you can do is you can just type in here a.shape and it'll give you the shape. So let us see what happens. So it has 7 columns, but there are no rows, so it has given 7 comma blank. So what I can do is I can close this in parentheses and I can define one more element, say 8, 9, 10, 11, 12, 13, 14. Go ahead and execute this and you can see 2 comma 7 because we have 2 rows and 7 columns available with us. So this is how you can actually find the size of your array as well as you can find the shape of your array. Now let us move forward and see what are the other operations that you can perform with NumPy module. So we saw how to find the size and the shape of an array. So we can perform reshape as well as slicing operation using NumPy array. Now when I talk about reshape, what do you actually mean by reshape? Can I get some answers, guys? Anyone? Alright, so Devon says when you change the number of rows and columns, that is called reshaping. Alright, fine. That is absolutely correct, Devon. And I've got correct answers from other people as well. Lavanya also says the same. So does Jason, Janice, Jagati. Alright, fine. So that is absolutely correct, guys. Now over here, there is an example. So we have 3 columns and 2 rows, which we have converted to 2 columns and 3 rows. Now let me show you that practically how you can do it. In a variable, and I'm going to start a numpy array and I'll have 2 elements in that. My first element will be 1, 2, 3, 4 and my other element will be say 3, 4, 5, 6. So I have a 2-dimensional array that contains 2 rows and 4 columns. Now I can convert that to 4 rows and 2 columns. Let me show you how to do that. You're just going to type in a is equal to a dot reshape and I want to convert it to say 4 rows and 2 columns. Go ahead and print this. So it has converted that to 4 rows and 2 columns as you can see in front of your screen. Now let me show you that earlier this is not the case. I'm going to type in a print statement here as well in order to show you that how it has reshaped. So earlier we had 4 columns as well as 2 rows, but now we have 2 columns and 4 rows. So this is how you can perform the reshape operation. Now let us talk about slicing. So slicing is basically extracting particular set of elements from your array. And the slicing operation that happens here is pretty much similar to the one which is there in list as well. So suppose if I want only this particular element, that is 3. So for that what I need to print, I'll show you, print a and the index value of 3 which is present at 0, comma, and the index is 2. Let me tell you how indexing happened. So this element will be 0, this element will be 1. Now if I want 3 from here, so from the 0th element, I want the index 2. Indexing starts from 0, 1 and 2. So that's why I've written 0, 2 and it should print 3 for me. Let us see if it does that or not. And yep, it prints 3. Now say if I want to print 4 and 6. Now for that what I need to do is I need to remove this 2 here and I'm going to put a colon that says all the rows including 0 and in that row I want only index 3. So we have only 2 rows, so if I would have written 0, 1 then it wouldn't have included this particular row. So if I have one more element here, so I can actually write here 2, so that won't actually include the element which is present at the second index. So when I say 0, this actually means all the rows that include 0 as well. So we have only 2 rows, it will include both the rows and at the same time it'll actually going to print the third index from both of these rows. So let me show you if that happens or not, and yep, it happens. We have 4 and 6 available with us. Now just to remove confusion, what I'm going to do is I'm going to add one more element and I'm going to give values to it, say 7, 8, 9 and 10. So now if I want 4 and 6, I can't just write 0, because if I do that, it'll print 10 as well. Let me show you that. Yep, it has printed 10. Now in order to avoid that, what I can do is I can write in here 2. So as I've told you, this is the 0th element, first element and the second element. So when I write 0, 2, it won't include the second element. It'll only include 0th as well as the first element. Now inside that, we have index 3 from both of these rows. That is why we'll actually get 4 and 6. Let us see if that happens or not. And you can see 4 and 6 is now available. So this is how you can perform slicing when we in NumPy arrays. Now what I'm going to do is I'm going to type in a equal to np dot line space. And now over here, first I'll write 1 comma say 3. And I want say 5 values between 1 comma 3. What this will do is it'll actually print the 5 values which are equally spaced between 1 to 3. So let me print this first. I'm going to type in print A and go ahead, execute this, and you can see that we have 1, then we have 1.5, then we have 2, 2.5 as well as 3. So if I would have written here 10, it will actually give me 10 values between 1 to 3. And yep, you can see we have the 10 values between 1 to 3. So this is how you can perform line spacing as well. So any questions or any doubts till now, guys, you can ask me. So there are no questions. Let me open my slide and we'll see what are the other operations that you can perform with NumPy. So we saw how to perform reshaping and slicing. Now let us see what are the other operations. So we are now going to find out the minimum, maximum, as well as the sum of our NumPy arrays. So let us go ahead and execute that practically. Let me remove all of this, and now I'm going to define one more NumPy array, np.array, and I want elements in it, say 1, 2, 3. Now if I want to find the element which has the maximum value, so what I can do is I can just type in here print a dot max. That's all, and it'll give me the maximum value in my a NumPy array, which is 3 obviously. If I want to find minimum value, so I'm just going to type in here min, and it'll print the same for me, which is 1. Now if I want to calculate sum, it is pretty easy. Just go on and type sum and it'll give you the sum. That's all, guys. It's that simple. I'm pretty sure there won't be any doubts here. If there are, you can just ask me. Fine, so there are no doubts. So Janice has a question. She's asking me, is it that simple to work with NumPy? Alright Janice, so let me tell you that whatever I'm telling you, these are all the basics that you require. After that, whatever your requirement is there, on that basis, you need to use those basic knowledge that you have and implement it. Now, the best way to do that, now the best way to understand any programming language is to play around with it. So you know the basics. With the help of those basics, just install PyCharm first, then try out new things like how should I get that, how should I get this, and if I'm not getting it, what is the reason behind it. So go on and try to discover new things. So the conclusion is you need to actually perform things practically. You need to make sure that you are not only getting the theoretical knowledge, you need to perform it practically. That's why I always say that side by side when I'm executing these practicals, you need to do that as well. Although you might find it pretty basic, but with the help of this knowledge, you can perform a lot bigger tasks as well. Alright, so Janice looks happy now. So let us move forward with our slides. So now comes the axis concept here, guys. It is pretty similar. We have a NumPy array which looks like this, and the rows are called axis 1 and columns are called axis 0. Now you must be thinking, what is the use of this axis? Suppose if you want to calculate the sum of all the rows, then you can actually use these axes and you can do that. Now let me show you practically how it happens. I'm going to open my PyCharm again and I'm going to show it to you. Let me remove this and let me add one more element here. 3, 4, 5. Alright. So if I want to find the sum of axis 0, it's very easy. Just go on and type print a dot sum and type in axis equal to 0. Go ahead and print this and you can see 4, 6 and 8. 1 plus 3 is 4. 2 plus 4 is 6. Similarly 3 plus 5 is 8. If I make this as axis 1 and print this, so it gives me 6 and 12 because 3 plus 2 plus 1 is 6. Similarly 4 plus 5 plus 3 is 12. So this is pretty easy, I know. Now let us go back to our slides and see what are the other operations. So there are many mathematical functions that you can perform with NumPy. That is to find the square root of each element. You can even find the standard deviation. Alright, so we have a question popped on my screen and Dave is asking me what exactly you mean by standard deviation. Alright, so standard deviation basically means that whatever the elements that are there in your NPY array, you find the mean of that and you actually find out how much each element deviates from that mean. So that exactly is standard deviation. I hope this answers your question. Alright, so yeah, these two operations can be performed with the help of NumPy. You can find the square root, you can find the standard deviation. Now let me show you that how you can do it. This is my PyCharm again. So now I'm going to remove this print statement here. And I want to print the square root of each of the elements that are there in my NumPy array, which is actually assigned to a variable a. So I'm going to type in here print np dot sqrt, that is square root of my NumPy array a. Go ahead and execute this and it has actually printed the square root of each of the elements. So the square root of 1 is 1, for 2 it is 1.414, for 3 it is 1.73, again for 3 it is 1.73, then for 4 it is 2, then for 5 it is 2.23. This is how you can find the square root of each of the element. Now when I talk about standard deviation, so you can find that by typing here. So now if I want to find the standard deviation, what I need to do is, instead of SQRT, I'll just type in here STD, and it'll give me the standard deviation, that is how much each element varies from the mean value of my NumPy array. And this is the standard deviation, guys. It's that simple. So this is how you find standard deviation. Now let us go back to our slides and see what are the other operations that are still left. Now these are the basic mathematical functions that you can perform with NumPy arrays, like addition, multiplication, subtraction, and division, and that will actually happen element wise. So basically you are performing matrix addition, matrix multiplication, matrix division, as well as matrix subtraction. Let me go ahead and show it to you practically. It is very, very simple, guys. So similarly, I'm going to define one more array, and let me name it as B. Let me remove this print statement. Now if I want to calculate the sum, so what I need to do is I need to type in print A plus B. That's all you need to do. But when I talk about list, again I'm telling you that when I talk about list, if I do that, it will concatenate both the lists. So if I want to print list, that is the addition of two lists, I need to use for loop. So that is where NumPy array stands apart, and it is pretty convenient. Go ahead and execute this, and you'll see that element-wise addition has happened. 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6. Similarly, 3 plus 3 is 6, then 4 plus 4 is 8, 5 plus 5 is 10. Alright, so this is how you can perform addition. You can perform subtraction by using the subtraction operator. Go ahead, execute this, and you'll find all zeros, because 1 minus 1, 2 minus 2, 3 minus 3, 3 minus 3, 4 minus 4, 5 minus 5 will be 0 only, right? No rocket science. Now go ahead and multiply it as well and see what happens. So you have 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is 9, again 3 into 3 is 9, 4 into 4 is 16, 5 into 5 is 25. If I go ahead and divide this, it'll give me all ones, and yep, it does. So this is how you can actually perform addition, subtraction, multiplication, and division using a NumPy arrays. Now let me go back to my slides and see what are the other operations present. So now guys, let me tell you one more thing. If I actually want to concatenate two arrays, I don't just want to add those two arrays. You can say that if my one array is a box, then I want another array on top of it. So let me show you how you can do that. Actually, there are two ways to do that. One is called vertical stacking and another is called horizontal stacking. Let me show it to you one by one. First, I'm going to show you vertical stacking. For that, what I need to do is print np.vstack and a comma b. Let us see what happens when I run this. So we have 1, 2, 3, 3, 4, 5. Then again we have 1, 2, 3 and 3, 4, 5. So this is called vertical stacking. If I want that horizontally, I'll just write in here hstack, and I'm going to run this now, and you can see that we have 1, 2, 3, then again 1, 2, 3. That means these two are present added horizontally, and we have 3, 4, 5. Again we have 3, 4, 5. So this is how you can perform stacking as well. Now there's one more thing that I want to show you. If I actually want to convert this particular NumPy array, that is A, to say a single column, so how I can do that? Just type in here print a dot revel. That's all you have to do. Go ahead and execute this. So you'll have 1, 2, 3, 3, 4, 5. So you have 1, 2, 3, 3, 4, 5. Let me go back to my slides and see what are the other topics that we are going to cover. Now come certain NumPy special functions. Now I'm going to talk about sine function and cosine function first. Now I hope all of us know what is a sine function and what is a cosine function. If you have any doubts with respect to what these two are, you can ask me. Although I'm pretty much expecting that you guys know this. Alright, so I've got answers. Alright, so I've got answers from almost everyone and they say that they know it. Fine guys. So what I'm going to do is I'm going to use this cosine and sine function, and I'm going to plot sine and a cosine graph. So for that I'm going to import a module called matplotlib. So you don't need to worry about that module because I'm going to discuss about matplotlib in the upcoming sessions. So there'll be a detailed session especially on matplotlib, so you don't need to worry about what exactly matplotlib is and how it works and all those things, because that'll be covered in the upcoming session. For now, what we are going to do, we are just going to use sine and cosine function in order to print their graph. So for that, I'll open my PyCharm and let me remove this and import matplotlib. NumPy.pyplot as PLT. Now we are going to define two coordinates, that is x and y. First, x is equal to np.arange 0, 3 into np.py, 0.1. Now I'm going to define y. So for that I'll type y np.sin x. Now I'm going to use PLT in order to plot the graph x comma y. Now finally show the plot. For that I'll type plot.show. You must plot.show to make a graphics appear. So plot.show, and here we go. Go ahead and execute this and you might be able to see a graph, and yep, it is here. Similarly, what if I change the sign to cos and should give me the cosine graph? Go ahead and run this and you can see we have a cosine graph as well. Similarly, if I write in here tan, that is any other trigonometric function, and I print this, so I get the graph for tan as well. So any doubts still here, guys? No doubts? Fine. So I'll open my presentation once more and we are going to see what are the other special functions that we can use with NumPy. Now NumPy comes with two very good functionalities, I would say, that is called exponential function and logarithmic functions. Now exponential, this e value is somewhere equal to 2.7 and we all know log. So when I talk about log, it is actually log base 10, and when I'm talking about natural log, that is log base e, I will write it as ln. So instead of that I've written log, that means log base 10. So you can perform these operations with the help of NumPy. Let me show you how you can do that. Or before that, if you have any questions with what exactly these two things are, you can ask me. This is pretty basic. Alright, so no questions, fine. I suppose everyone know about this. So I'll open my PyCharm. Let me remove this. And I'm going to define a NumPy array. Let it be AR equal to np.array 1, 2, 3. Now I want to calculate the exponential value. I'm going to throw in a print statement and I'm going to write in here np.exp AR, and this will calculate the exponential value for me, and let us see if it does that or not. So yep, as I've told you earlier as well, value of e is 2.71. So e to the power of 1 is actually equal to e, so it has returned the e value, but e to the power of 2 will be somewhere equal to 7.38. E to the power of 3 will be somewhere equal to 20.0855. Now in order to calculate log, what you can do is you can just type in here log. Now this will give you natural log. So when I talk about natural log, it is nothing but ln, or you can say log base e. But if I want to calculate log base 10, so I need to type in here 10. First let me show you how you can find the natural log. Just go ahead and execute this. Alright, so when I talk about 1, so e to the power of 0 will be equal to 1, right? So log or ln AR equals to 0. Similarly, the other values as well. Now if I want log base 10 instead of ln, or you can say natural log, I can just write in 10 and go ahead and execute this and you'll find log base 10 values. So obviously when answer is 1, that means anything to the power of 0 is equal to 1. So the answer will be 0 here, and similarly we have other answers as well. If you're unsure about it, you can open your calculators and do that. Alright, so Lavanya says, I trust you. Thank you, Lavanya, for those kind words. Let me open my slides once more, and by this we come to the end of today's session. If you have any questions or doubts, you can ask me right now. Janice says, amazing session. Thank you, Janice, for those kind words. Jessica says, very informative. Thank you, Jessica. Alright, fine guys. So let me give you a brief summary of what all things we have discussed. First, we saw what exactly is NumPy. Then we compared NumPy with lists, and we understood why we use NumPy instead of lists. Then we saw various NumPy operations like slicing, stacking, addition, subtraction, multiplication, all those things. Then we focused on certain special functions like sine and cosine functions. Thank you guys for attending today's session. This video will be uploaded into your LMS so you can go through it. If you have any questions or doubts, you can ask our 24/7 support team, or you can even bring your doubts in the next class as well. Thank you and have a great day.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!